Alright, now let's try the second example on variation of parameter. Okay, so for this example now, our first step again is to identify A. So in this case, A is 1. And then fx is the right-hand side term of our equation, which is x plus 1 exponent to x. Alright. Okay, second step, we need to find YH. Okay, so first the characteristic equation. So from the characteristic equation, m squared minus 4m plus 4 equal to 0. Okay, so it is easily can be seen that we can factorize, okay, m minus 2, m minus 2. Okay, so therefore we have m1, okay, equals 2 and m2 is also equals 2. So in this case, we have the equal roots. Okay, in that case, our YH then is going to be a plus bx exponent 2x. All right. And then based on this YH, we should be able to write our Y1 and Y2. Okay, so if we expand this term here, this expression here, then we'll have a exponent 2x plus bx exponent 2x. Alright, so based on the first term, y1 is then exponent 2x. Okay, if you can recall, for the y1 and y2, we need to ignore the constant. Okay, so for this one, y2 is x exponent 2x. Okay, and then next step is to find the Wronskian W. Okay, let's write one more time. Y1, Y1 prime, Y2, and then Y2 prime. Alright, so this is now exponent 2x. And the derivative of exponent 2x is 2 exponent 2x. And Y2 is x exponent 2x. Alright. But for the y2 prime, so careful here, since we have two terms here, x and exponent to x, so the derivative to the y2 is not straightforward. So you need to know here, you need to apply the product rules, right? So just imagine that u is the x and v is the exponent to x. Then if I let v, then I have exponent 2x. If I differentiate u, that is 1. And then I let u, which is x, and I differentiate v, then we have 2 exponent 2x. Okay? And then finding w, okay? So I will have now exponent 2x times exponent 2x plus x 2 exponent 2x. Okay, then I will have exponent 4x. So I'm going to write directly. Okay, exponent 4x plus 2x exponent 4x. Okay, minus with the multiplication of these two. Okay, so I have minus 2x exponent 4x. Okay, so we can see that we can cancel out this term and also this term. All right, so what's left now is just exponent 4x. That is our w. Okay, next we need to find the u. U again is the negative to the integral of y2 fx over a times w dx. Okay, so we have here negative integral y2 is x exponent 2x. Okay, multiply with the fx. So look back at your fx, which is x plus 1 exponent, what do we have just now? Exponent 2x, right? Exponent 2x over, so our a is 1, our w somehow is exponent 4x, and we need to have the dx here. So now try to simplify. Okay, the term that we have here. So you can see this exponent multiply with this exponent will gives you exponent 4x, which can be cancelled out or simplified with the exponent 4x at the bottom. So basically we have the integral of x times x plus 1. Okay, so we have x squared plus x dx. So this is pretty straightforward. Okay, very straightforward. And then we have negative, don't forget the negative, so put carefully the bracket, because if we expand this, then we have negative x squared minus x. Okay, so we have here x cubed over 3 plus x squared over 2 plus some constant c. That is our u. Okay, now move to our v. V is the integral of y1 fx over aw dx. Okay, so similarly we have the integral of y1 is exponent 2x. The fx is again x plus 1 exponent 2x over a is 1, w is exponent 4x. Don't forget the dx here. So similarly, this exponent and this exponent can be simplified with the denominator. So what we have eventually is the integral of x plus 1, okay, which is x squared over 2 plus x. Put some constant d here. All right. So finally, our y, which is our answer, y is then, okay, u y1 plus v y2. So put things together, u is, so we have a big bracket here, so you can multiply negative, okay, inside the bracket. So we have x cubed over 3 plus, sorry, this is supposed to be minus. Okay, so minus x squared over 2. So we have here plus some constant c. Doesn't matter if you want to put a negative or positive c, because that is another constant. Okay, you can even write as c. Okay, plus, sorry, y1. Multiply with the y1. So our y1 is exponent 2x. So that is uy1 plus v. V is x squared over 2 plus x plus d times your y2, which is x exponent 2x. Okay, so you still have c and d. All right, so if you have extra time, then you can expand the bracket here. Okay, or basically you just can stop up to that. All right. So those are the steps. Okay, these are the solution for example 16. Okay, okay, so now I want to highlight here. Okay, so what if, okay, so what if I have the initial condition? Okay, what if I have the initial condition? Okay, so for example, you are given y0 equals 1, for example, and then y, okay, 1 equal to 0. Okay, so we need to use this condition at the end, apply at the end of the steps. Okay, so basically after y here, then we have additional step. We need to apply y0 equals 1, and then from here, okay, we are supposed to get the constant, okay, either c or d. Okay, and then we apply the second one. Okay, so based on this, we should be able to get c and d. And after that, we write down our final answer with the value of the constant c and d. Okay, so I hope everybody clear on that, because sometimes in the problem you were given the conditions. All right, so that's the solution for example 16.